Hey guys, this question is from one of the AP free response. This is 2009 Form B, question number 4, and this is a calculator question. I'm sorry, this is not a calculator question because they're not actually telling you to solve; they're just telling you to set up a bunch of stuff. So we will. Well, first, I think it'd be a good idea if we just actually graph this one. So let's just pretend they don't give us the picture. That wouldn't happen because they don't want you to have to take the time to graph it. So let's just look at this old-fashioned pre-calc style. Okay, let's go pre-calc style here. So this is my this will be my polar curve, and I think, do you guys remember I should have brought home a piece of graph paper, but it had the circles on it because it would help you figure out, like, you know, how far you can go out for your R values. But I'll do my best. Let's see what we can do here. Old-fashioned now. Old school. Theta, R. Let's just do all the basics. 0. If, excuse me, cosine 0 is obviously 1, so 1 minus 2 would be negative 1. So at theta equals 0. So, right, so here's 0, right, 0 radians. Here is, let's see, this will be about pi over 6, pi over 4, pi over 3, pi over 2, of course, and then what's this one going to be? 2 pi over 3, 2 pi over 3, right? Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So that's 2 pi over 3, and then we have the 3 pi over 4. That's around, you know, the 45 degrees from here, so 135, and then we're going to do what, 5 pi over 6 over here, and then pi. Okay, so unit circle. This is old-fashioned unit circle stuff. So at theta equals 0, right, these are all my theta values. At theta equals 0, I'm supposed to be negative 1 away. So obviously positive 1 would be this way along the 0. Negative 1 is this way. So my first point is here. When we graph this, that's where we're starting. That's why it's you know, we got to start 0 to whatever. And I think somebody had asked about, you know, well, what do you go to? Well, let's just graph it and see what happens. Let's go pi over 6. Pi over 6. Cosine pi over 6. That's going to be the longer one. That's radical 3 over 2. Times 2 is radical 3. So this is 1 minus radical 3, whatever that is. I don't know exactly what it is, but you know what? I do know it's negative. So even without a calculator, I can tell you about where this is. So at pi over 6, which is my angle, I have to go back about 0.7, whatever. So at pi over 6, I'm going back about 0.7. So maybe somewhere around here. Again, if I had all the circles, it'd be a little easier to estimate this, but it's not quite a full 1, so it's a little less than that. It might even be a little shorter, but that's pretty close. So again, I am whatever this is. Let's just say, oh, screw it. We got a freaking calculator. Let's just use it. 1 minus, I think it's about 0.7, negative 0.7, radical 3. Okay, so this is about negative 0.73, so almost negative 3/4. So if negative 1 was here, well, the negative 3/4 would be about here. Okay, actually it should be probably a little more on an angle here, probably about here. I got to line it up with the pi over 6 angle, right? So maybe about here. Just make the dot really, really big, so I have a very wide margin of error there. Okay? How about pi over 4? Okay? Radical 2 over 2 times 2 is radical 2. 1, oh great, 1 minus radical 2. Well, radical 2 is about 1.4, so this is going to be about negative 0.4. So I know it's less. So at pi over 4, I have to go back, but only a little bit less. So I'm going back to maybe here. How about pi over 3? Cosine pi over 3, that's the shorter one. That's a half. Half times 2 is 1. 1 minus 1 is 0. And now we're back to here. So my curve starts at theta equals 0 and gets back here at pi over 3. And in the actual question, I know this is the region, and that's why you go from 0 to pi over 3. Let's keep going, because some of you probably could use a little review anyway. I know somebody had asked in class, I think period 7, for me to just teach polar. I didn't really have the time for that, but you know what? I can integrate it into this. Oop, see what I did there? See what I did? See what I did? Alright, so that's pi over 3. How about pi over 2? Cosine pi over 2 is 0. Okay, so that's 1. So that's at pi over 2, I'm 1 away. So it doesn't go here because there's obviously stuff in between. it's got to just come back relatively quick. So why don't we pick something in between here, even if it's not on the unit circle, just to get an idea of what this is doing. So between pi over 2 and pi over 3, how about pi over 2.5? Okay, just for the sake of discussion. Now that there's no way to obviously get an exact answer there. So 1 minus 2 cosine pi over 2.5. So it's 0.38-ish, and that's all I care about. So at this angle, this weird angle that's not on our unit circle, I'm 0.38 units away. So 1 would be like here, so I don't know, it's a little less than half, something like that. So really in between there's this moment. It's not going to go straight up, it's going to go back to like here. Okay, now let's just do all the regular ones. 2 pi over 3. Let's see, 2 pi over 3, that's negative a half. That makes this positive 1, so that's 2. So at 2 pi over 3, let's see if 1's here. Let's say 2's here, so maybe, I don't know, maybe here. Because remember, it's a circle here. So, I don't know. How about that? How about, I think I shorted myself on some paper here. Let's see. 3 pi over 4. That's going to be negative radical 2 over 2, so that's going to be positive radical 2. So 1 plus radical 2. So that's about 2.4. Okay. So at this one, I'm a little further. If this is 2, it's about 2.4, maybe here. And we're just building as we go. So I feel like we're building like railroad tracks. Let's see. How about 5 pi over 6? So cosine 5 pi over 6, let's see. That's going to be negative radical 3 over 2. So that's going to be positive radical 3, so 1 plus radical 3. So about 2.7. So at 5 pi over 6, 2.7, well, that's got to be a little further, so maybe here. How about that? And of course, last but not least, how about pi? Cosine pi is negative 1 times negative 2 is positive 2, plus 1 is 3. Of course, I don't have enough room for negative 3 units away going along the pi line. So let's see. I can almost, you can almost tell it's basically like right here. So 3 units away going along the angle of pi would be somewhere out here. And if we look at that graph, I have it in there. I have the same window that they have on the AP question. Let's see. And there you go. Okay? So again, the question wants just this area here. And how do you find those values? Well, we're starting at 0 and we're going to when we get back to the here. And what I would have done, normally I would literally just take this when is 1 minus 2 cosine theta equal to 0. And that's how I know to find where that point is. So that would be 2 cosine theta equals 1. Cosine theta equals a half. When does cosine theta equal... Oops, sorry, I got cut off there. When does cosine theta equal a half? When theta equals pi over 3. Okay? Alright, so there's sort of a mixture of, okay, there's an AP problem that you need to solve, and a little bit of polar review on the graphing. Now again, this is not... You're not doing this. But for whatever reason, some of you just never really caught on to this when you did it in pre-calc, or I guess technically some of you maybe never saw it in pre-calc, which is blasphemy, but it is what it is. So here we go. We got to survive it. If you need more help, obviously I'll do what I can, but hopefully this is enough to get you through. Okay? I'll talk to you later. See ya.